Looking for a refrigerant leak on this 1983 Mercedes 300 SL. So it came to me with 0 psi. It had no refrigerant in it at all. It was at a neutral ambient pressure. I'm performing a high pressure nitrogen leak decay test, and as you can see right here, if it will focus, I am 6 minutes into the test and I have dropped 1.9 psi in 6 minutes. There is a leak and I am looking for it. Now I went around with the ultrasonic leak detector, and it's a high frequency, and high frequency is directional. So if you're, and it could bounce a little bit, but the more you're out of direct line of sight of a high frequency, they don't absorb very well. I mean, they get absorbed. Unlike a low frequency, bounces and spreads out. High frequencies are very directional. So I haven't been able to locate it yet with the, come on, ultrasonic leak detector. I can see that I have temps. Here we are, we're down to 2 psi now. You even leak test all your fittings to make sure your equipment is not the problem. I used the most common on these Mercedes as they're getting this old. We're starting to see them start to fail at their crimps. That would never happen before. When these were in their 10, 20, 30-year-old lifespans, these crimps usually and these hoses would never fail. But now that they're getting 40 years old, we're starting to see some failures even on this material that was super good. Under the dash, could not pick up anything under there, but I can't get direct line of sight without taking things apart to get to the expansion valve, to get to the fittings, to use the ultrasonic leak detector. You got to get time, tear down time for that. That's extra labor because that gets in time. Now you can see this thick stuff that I have on here, the shiny stuff, and I don't know if you can see how thick this actually is. It is so thick that when it lands on the floor, I don't know if you could see this. Well, let me flip the screen. Can you see that actually has a height to it? It's not just absorbing into the concrete. It actually stands up. This stuff stays thick for a long time, and it stays liquid for a long time to help you look for the common leaks. Like this case right there where you see that seam at the case, that's a common leak point. That case, the seal there will get old and brittle, and it'll lose its elasticity and it'll leak. Same with the front shaft seals. And it kind of looks like this front clutch. Look at that gap. That's a huge gap. Let me see if I can get in there and see some light. I'm gonna zoom in there. Do you see that? That's an excessively large gap. And by that burnt marks and the rust that's on there, I'm gonna say this clutch has slipped and got hot. And the heat exceeded what the paint could handle, and the paint flaked off, and that leaves the metal exposed, and that's why they rust usually. So we have compounding problems here. But this has at least not been retrofitted over in its past. And so it still came in with the original fittings on it. And so I'm gonna jump in onto this one and I'm gonna evacuate it. I'm gonna add UV dye. I'm gonna fill it up and run it and try to make it leak under pressure with refrigerant and try to find a leak that way. Hopefully the compressor, I'm gonna notate the clutch does need to be adjusted. That's could be a potential problem because when the clutch gap gets wide, when the magnetic field and metal gets hot, the resistance goes up and the magnetic field goes down, and it can no longer pull that clutch gap in when the compressor gap is too wide. And the symptoms will be, my AC works for 10, 15, 20 minutes, and then all of a sudden my AC doesn't work. Well, in that 10 or 15, 20 minutes, the coil and the metal were cold, the resistance was down, the magnetic field was strong, and it can overcome that large gap. But once it gets hot, the magnetic field gets rid, and the next time it cycles and it releases the clutch, and then when it gets the call to come on again, it can no longer overcome that gap because now it has the heat of the engine, compression, the gap, the windings of the coil get hot, and now it gets weak. And if you adjust the gap and you bring the gap back close again, when the magnetic field gets energized, it can easily close the gap. So I'm going to jump on. You'll see next video, I'm going to vacuum, inject dye into this thing, fill it up, and we're going to go in here. And this is looks like he's going to have to put a new pad. Remember, these had the reflective aluminum pads underneath them, and pretty clean for 199,000 miles. 199,000. The dash looks beautiful, the interior looks beautiful for a 1980s car. Look at this thing. Look at the headliner. The headliner is nice. For 199,000, this is all the wear that's on the seat. That's pretty damn good. The car is super clean, so it's very much worth investing in. This is a beautiful car. So we'll give it some tender loving care, and we'll see in the next video what the condition of the air conditioning is.